Welcome to Math Olympiad questions. Okay, this is the part 10 of the video. Uh, we'll do some problems which are good for Olympiad and IOQM and engineering entrance exams. This is meant for students from class 8 to class 12. For class 8, it will be difficult, but they should start doing these problems. For class 12, 12 students, these are all must. Okay. Okay. Two circles S1 and S2 of radii 8 units and 3 units respectively are tangent to each other externally. Okay, they are touching each other. AC and BD are their direct common tangents with AB on S1, CD on S2. Find the area of quadrilateral ABCD to the nearest integer. Okay, so if you draw the diagram, this is S1 and S2. ABCD are here. These are the two tangents. Okay, they'll meet at point O. These are the other points which I am taking. M is the center of this S1 circle, N is the center of S2 circle. And if you draw a card, it will touch at F here, E here. Okay. So before starting, let's learn one concept where you have to derive this formula for OM and AC. If two circles are touching each other tangentially or externally, what is the length of OM and AC? Okay. This one we'll learn first and then get into the problem. Okay. Let the radius of bigger circle is r and radius of smaller circle is small r. Okay. So this is the given diagram. So find OM first. If you see OAM and OCN, both are 90 degrees because they are tangents to the circle, so they are 90 degrees. Okay. And triangle OAM will be similar to OCN. OAM will be similar to OCN because this is the right angle triangle. And this is also at 90 degrees to this line, 90 degrees to this line. So AM and CN will be parallel, and we can easily prove that these two triangles are similar triangles. Okay, once you know that OM by ON equal to AM by CN, okay, which is OM by ON. ON is nothing but OM plus small r plus capital R, okay, equal to AM by CN, which is small r by capital R. Okay, now you just to simplify it, you will get OM value as small r into capital R plus R divided by capital R minus small r. Okay. And the second one is AC, right? How do you find AC? In OAM. Okay. OA square equal to OM square minus AM square. Pythagoras theorem. Simple. Okay. OA square is equal to, we know this already. Okay. OM square, that is here, OM square. Okay. Minus AM square. AM is R square. Okay. Now you simplify it, what you will get OA is 2r square root of capital R small r divided by capital R minus small r. Okay. And we know that OAM, OCN are similar triangles. Already we have seen here. Okay. So OM by MN, OM by MN equal to OA by AC. Okay. So AC equal to, from this AC you can derive, which will come 2 square root of capital R small r. Okay. So note down these two values. These two values are useful for us. We will substitute these values into the problem there and then we'll solve that problem. Okay. So AC is equal to, we just now solved, AC equal to 2 square root of capital R small r, which is 6 root 2. Okay. And OM equal to, this is the expression, so which is equal to 9. Okay. OM equal to 9, AC equal to 6 root 2. Now, once you know these two, OAM and OFM, okay, this is OAM and AFM, sorry. AFM, you have a 90 degrees here, 90 degrees here, okay, and this is a common angle. If two angles are same, from AA rule, we can tell that these two triangles are similar triangles, okay. So once they are similar, you have to take appropriate ratios, okay. FM by AM, FM, okay, we are trying to find the value of FM because to get this quadrilateral ABCD, I need to know this value. I know what is the distance between this M and N. Okay, this is capital R plus small r. But I don't know what is the distance between E and F. Correct? So I need to know this FM value and EN value. Okay. So FM by AM equal to AM by OM. Okay, FM equal to R square by 9. R is 3, small r is 3, so FM equal to 1. Similarly, you can get En equal to 2. Okay, so once you solve this one, this is easy. EF equal to EF. This is what distance I am trying to find out. EF equal to Mn minus En, correct? Mn. I am cutting up this En part and then adding this Fm. Okay. So which is equal to 8. Now I have trapezium where AB and CD are parallel. Okay, so I need to just know length of AB and CD. That is simple because AMF is a right angle triangle. We know AM value, we know FM value. So I can get AF value. AB is twice AF, correct? So AB equal to twice AF, which is equal to 2 times square root of AM square minus FM square, which is equal to 4 root. Similarly, CD equal to 8 root 2. Now I have all the values. Okay, area of ABCD trapezium is half into sum of parallel lines into height. Height is EF, right? So if I substitute all the values, I'll get 48 square root of 2. The nearest integer is around 67. Okay, this is the answer. Yeah, next. Let ABC is the equilateral triangle with side length 10. A square PQRS is inscribed in it with P on AB, Q on Q, comma R on BC, S on AC. Okay, if the area of the square PQRS is mentioned in terms of m plus n root k, where m, n and k are integers, then what is the value of square root of m plus n by k square? Okay. So why this normally they ask is most of the Olympiad questions they want only 2-digit answer. Always they wanted 2-digit answer. So they try to get into a 2-digit answer. What we need to find out is the area of the square. Okay. Once you know the area of the square, this part is very simple. Okay. So yeah, this is the diagram. It looks like this. ABC is the equilateral triangle, side 10. PQRS is the square inside the triangle. Okay, touching the sides PQRS. Okay, and let's say this point is M and this is N. MN also equal to either PQ or PS because it's a square, right? So first thing is let's get into a single variable equation where that single variable should be side of this square, any of the sides. Okay. So triangle APS is similar to triangle ABC. APS similar to ABC because these two are parallel lines anyway. PS and BC are parallel. So we can easily prove. So AM by AN equal to PS by BC. Okay. BC is 10, so PS by 10. Okay. Now 1 minus AM by AN is equal to 1 minus PS by 10. Okay. Which means AN minus AM divided by AN equal to 10 minus PS divided by 10. Okay. Now, if you see AN minus AM, AN minus AM, which is nothing but MN. So, MN by AN. MN is nothing but PS again, same. MN and PS are same, right? Because it's a square. So, now we got everything into single equation. Okay. 10 minus PS by 10 equal to PS by AN is 5 root 3 because side is 10. So, altitude will be 5 root 3. Now you simplify this one, you will get the value for PS. PS is equal to 50 root 3 divided by 10 plus 5 root 3. Okay, now PS is the side. So area of the square is square of this one, which is nothing but this value. Okay, which is in the form of m plus n square root of k. So we can clearly see m is 2100, n is minus 1200, k is 3. So the given expression square root of m plus n divided by k square is 10. That's the answer. Next. Angular bisectors AI and CI meet the circumcircle of triangle ABC at points A1, C1 respectively. Okay, I'll show the diagram and explain. It's easy to understand, but most important thing in this question is to draw this diagram correctly. Okay, so you have a ABC triangle, okay, and you have a circumcircle that is blue color, right? It is meeting at points A1 and these angular bisectors of A and C. Okay, angular bisectors AI This is AI, A1 actually, or AI, whatever. AI and CI. Okay, or A1 if I call it A1, C1. Okay, they meet at, these are the angular bisectors of these two angles. They meet the blue circle, that is circumcircle of this circle at A1 and C1 points respectively. Now, the circumcircle of AIC1, okay, this point is I, okay, this is the point I, okay. Now, circumcircle of AIC1, that is this green, okay, light green. This is meeting the triangle at C0, okay, triangle at C0 and circle at C1, okay, okay, because this is a extended and this is the triangle I'm talking about. So obviously this, it will go through these points, these 3 points anyway. This is the circumcircle, okay, and the point here is C0. Similarly, the circumcircle of A1IC is the dark green line meets the triangle at A0, okay. Now what we need to prove is this A0, A1, C0, C1, they are all collinear. This is what we need to prove, okay. So the diagram looks very complicated, but the problem is very simple if you know the circle card rules, okay, sector and card rules, okay. C1A is a card on the blue circle. On the blue circle I am taking, not green circle. Blue circle, it's a card. So it will subtend equal angles on the same circle. That is, one is here, okay, one is here, other one is here, okay. Initially, I assume this is Y, so this also will be Y. These two angles are same, okay. Similarly, okay, similarly, CA1, this is the card on blue circle. This also subtends equal angles. One is here, X, angle X. Other one is here, CC1A, A1. CC1A1. This is also X. Okay. So now what we need to prove is there is a line, C1A1, there is a line. We just need to prove C0, A0 are on the same line. That's it. Okay. So now let's take IC0. Okay. IC0, if I take these 2 points, this is a card, this is a card, and this card subtends what angle? Let's see. This is also X angle. Okay. C0 AI is X angle X. Okay. IC1 C0. This is also X. Okay. Which means if this angle is X, C0 definitely lies on C1 A1. Correct? Only then you will get this angle X. Okay. Because we already proved this is X angle. With this card also, we are getting same angle, which means C0 should lie on C1 A1. Similarly, okay. Similarly, IA0, if you take IA0, this card, okay. If you take this card, this is subtending an angle of Y here, ICA0, Y angle, IA1A0. This is also Y angle. So, previously we already proved this is Y angle. Now, with this card also, we are proving this is Y angle, which means A0 lies on C1 A1. Okay, that means we proved that these 4 points are on the same line, which are collinear. Okay, hope you understand this. The diagram is very important. I choose this one as a complicated diagram problem. You should draw the diagram correctly. Okay, yeah, next. Okay, the next one is a semicircular paper is folded along a chord such that the folded circular arc is tangent to the diameter of the semicircle. Okay, the radius of the semicircle is 4 units. And the point of tangency divides the diameter into 7:1 ratio. If the length of the crease, the dotted line in the figure, is L, then determine L square. Okay. So understand the problem carefully and draw the diagram correctly. Okay. Geometry is all about drawing the diagram correctly. Okay. So the first circle we are talking are the semicircle. Okay. We don't need to draw this complete. I just draw full circle here. Okay. Okay. So AB is the diameter of this one, which is radius is 4 of this semicircle. So this is total is 8. Total is 8. Now let's see how to divide this. Okay. First thing, AB is 8. And I have folded this paper along this dotted line. Okay. So this bottom arc is exactly mirror image of the top arc here. Okay. Both are exactly mirror images of each other. Okay. Now another circle is drawn with this arc. Okay. With this arc, another circle is drawn, which is the tangent to the diameter here at point D. Okay. Tangent to the diameter at point D. So the G here, the two circles where they are meeting need not be B. Okay. It will be different from B. Okay. This is important. Most of the explanations I have seen online, they have shown G as B, but it is not. Okay. Both are different. Understand that carefully. Okay. And this EG is exactly the mirror cut of this arc and this arc. Okay. These two arcs. Okay. Now, the question is, this is this circle also radius will be 4 units because exactly from the same curve, same arc you are drawing a circle. So this also will be 4 units. Okay. Now, the tangential point D, okay, divides this diameter in 7:1 ratio. So that means this AD will be 7 units, DB will be 1 unit. Correct? Because total is 8. So 4 units of this radius AO, OD will be 3 units, DB will be 1 unit. Okay. Now you have this. Now we need to find out GE square. Okay. This is dotted line is nothing but GE square. That is L square. Okay. So now you understood. So from the center of the second circle, draw a perpendicular. Okay. To the draw a radius to the tangential point. This will be perpendicular to the diameter because this is the point of tangent. Okay. This is the point of tangency, so that will be 90 degrees. Now, once you know this, ODP is a right angle triangle, correct? Or PDO is a right angle triangle at D. Okay. PO will be equal to square root of PD square plus OD square. PD is 4 units radius, OD is 3. So, obviously, OP will be 5. Okay. Now, OP we know. Now, PF is exactly half of PO. Why it is? This is, I said, these 2 points, it is mirror image, two circles. Okay, these are the two circles. Okay, concatenated at 2 points, EF, then F will be the midpoint of these two connecting centers, right? The line connecting the centers, F will be the midpoint. So PF equal to half of PO, okay, which is 5/2. Now you know this already. So either you can draw PE or PG, both are same. Okay. PE will be 4 units. PF is 5/2. Now we need to get EF. That's it. G is twice of EF, right? So in the PEF, again right angle triangle left at F, EF square equal to P square minus PS square, which is equal to 39/4. EF square is 39/4. G square, which is L square, is equal to 2 times EF whole square. Okay, that is 4 EF square, which is 39. So answer is L square is 39. This is the answer. Okay. So it's very important to understand this diagram. That's why I chose this question to draw it very carefully and differentiate these points here. If you are drawing a line EB, suppose if this dotted line you think is EB, then it's wrong. If it is EB, then F is not exactly the midpoint of PO. F is not the midpoint of PO in that case. Okay, this is what exactly the question is. Okay, next. Yeah, next question is, consider a right angle triangle ABC whose hypotenuse AC is of length 1. Okay, AC is 1 length, you can see in the diagram. The bisector of angle ACB intersects AB at D. Okay, so this is CD is the angular bisector, so theta, theta. Okay, this is D. If BC is X length, BC is X, what is the length of CD? Okay, so we need to determine Y. Okay, let's use just a simple Pythagoras theorem to solve this first, and then we'll do a easier way. Okay, I want to just show how much difference the both ways are. Okay, CD is angular bisector, so AD by DB, CD will bisect AB into, okay, AD by DB equal to 1 by X into the AC by BC ratio, right? So AD by DB will be 1 by X. Okay, now next. You add plus 1 to both sides, AD plus DB by DB equal to 1 plus X by X. Okay, this is nothing but AD plus DB is AB. Okay, so AB by DB equal to 1 plus X by X. Okay, now in triangle CDB, okay, in this one, y square minus x square equal to db square. Again, Pythagoras or Bodena theorem we are applying. So we got db. Now you have a equation for db, okay, and we can replace it here, right? So 1 minus x square equal to ab square. 1 minus, in triangle ABC, 1 minus x square equal to ab square. Okay. So now you have two equations. Okay. Three equations actually. This is first equation, second equation, third equation. You divide these two equations, you can remove the one LHS and RHS side, you can equate, right? So AB square by DB square equal to 1 minus x square by y square minus x square. This is equal to 1 plus x whole square by x square. This is one, right? Same one. 1 plus x whole square by x square. Now I have all x terms and one y term. So you just need to simplify it carefully. Okay, once you simplify, you get the value, but simplification is not so easy. So this is a lengthy procedure here. Okay, so y you will get is square root of 2x square by 1 plus x. This is the answer. Okay. Now let's do the same problem using trigonometry, because whenever you see two angles, okay, two equal angles, cos theta you can apply and cos 2 theta you can apply, or sin theta you can apply, sin 2 theta you can apply. Trigonometry is very, very easy. Okay, so let me show you that second method of the same problem. Okay, so now you know that in triangle CDB, cos theta equal to, cos theta is x by y, correct? In CDB, cos theta equal to x by y. In a triangle ABC, cos 2 theta equal to x by 1, which is x. Okay, now you have these two, and you know the relation between cos theta and cos 2 theta. Cos 2 theta is nothing but 2 cos square theta minus 1. Okay, so you substitute the values x equal to 2x square by y square minus 1. Okay, or 1 by y square equal to 1 plus x by 2x square, or y equal to square root of 2x square by 1 plus x. This is very easy method, right? Trigonometry. Only thing is you need to know the equations, and most of the times whenever you see a cos 2 theta, you have to write it in 2 cos square theta minus 1 and see most of the problems will be get resolved. Okay, if you know cos 2 theta and cos theta values, then it's very easy to solve the problems. Okay, because there is a relation between cos 2 theta and cos theta. So this is most important trigonometric equation to remember. Okay, remember this. This will help you a lot. Okay. For some positive integer n, the number 110 n cube has 110 divisors, including 1 and itself. How many positive integer divisors does 81n have? Okay. Yeah, this is a very good problem, interesting problem. So let's do it. So most important thing to remember, the moment divisors came and a number is given, okay, you have to go to the prime factor method. Okay, if a number prime factor is in the form of a to the power of x, b to the power of y, and c to the power of z, okay, then it will have x plus 1 into y plus 1 into z plus 1 divisors. Okay, this is the important thing to remember. Okay, now once you know this problem is easy to solve. Now you take 110 n cube. 110 I can write it as 2 into 5 into 11 into n cube. Okay, now I know that the number of divisors it will have is, if if it is n cube is different from 2, 5 and 11, then it will have 2 into 2 into 2 into some 4. Okay, because n is different from 2, 5 and 11, correct? But that is wrong because 110 is equal to 2 into 5 into 11. So n cube has to be one of these three. It cannot be different from any of this. And n cube cannot be 1 also. N cannot be 1 also. Why? If you take it as 1, then this number will become 110. It will have only 3 divisors. But he is clearly said 110 n cube has 110 divisors, not 3. Okay, right? Not 3. I mean 2 into 2 into 2. That is, you will get 8. Actually, 8 divisors you will get, but that's not true, right? So you need to get 110 divisors. That means n cube is one of these three numbers. Okay, so let's assume this is in the form of e to the power of x, b to the power of y, and c to the power of z. Okay, now x plus 1 into y plus 1 into z plus 1 equal to 110, which is 2 into 5 into 11, right? It should be in this form. Now you should get, let's say, 2 here, 1 plus 1, okay, then 4 plus 1, and maybe 10 here. Okay, correct? So x equal to 1, y equal to 4, z equal to 10. What is that number? Which one A, B, C is 2, 5 or 11 doesn't matter for us. What we are interested is in x, y, z's now. Okay. So this is x equal to 1, y equal to 4, z equal to 10. Then it will become, correct, 2 into 5 into 11, which is 110. Right. Now I will rewrite this now into this form. 110 n cube equal to a power 1, b power 4 and c power 10. Okay, A, B, C are any of this one. Okay, now n cube will be equal to, in that case, n cube is equal to, okay, b cube by c power 9. Why I am taking one of this number? A into b into c is 110, correct? So I am removing a, b, c. So I am left with b cube and c to the power of 9. So n is equal to b into c cube, b into c cube. Okay, now 81n will be, if this is n, this is my n is b into c cube, 81n is equal to 3 to the power of 4 into bc cube, correct? And b and c are different from 3. They are either 2, 5 or 11. bc's are either 2, 5 or 11. So all three are again in the prime factor method. So 81n will have how many divisors? 4 plus 1 into 1 plus 1 into 3 plus 1. That is 40 divisors it will have. Okay. So hope you will understand this problem. Go through this once again. It's very easy to understand, and there are several problems I am seeing in Olympiad coming on this principle. Okay. Next. How many numbers formed by rearranging the digits of 2, 3, 4, 5, 7, 8? Okay, and these numbers should be divisible by 55. So we need to apply rule of 5 divisibility and 11 divisibility, right? So simple. Let the digits be A, B, C, D, E, F in the same order. Okay, number should be divisible by 5 and 11. Okay, to be divisible by 55. 5 rule is, we know last digit should be 5. So 5 or 0 basically, but given digits are only this. Okay, so out of this, only possibility is last digit, which is f is equal to 5. Okay, now we fixed f as 5. Okay, now 11 divisibility rule, there are two rules. One is sum of even place digits equal to sum of odd place digits. Okay, but given sum of digits is 8 plus 7, 15, 15 plus 5, 20, 20 plus 4, 24, 24 plus 5, 29. So 29 you can never make equal, right? 29 you cannot divide into even and odd, I mean 3 and 3 numbers which can be equal, correct? They cannot be equal. So this rule you cannot apply. You have to check the second rule of 11 divisibility. That is, sum of even place digits minus sum of odd place digits should be multiple of 11. Okay, the difference in even place, sum of even place digits and odd place digits should be multiple of 11. This should be possible. Okay, let's see how it is possible. Let's say A plus C plus E minus B plus D plus F. Okay, this is all negative. Okay, congruent to 0 mod 11. Okay, or F is 5, we already fixed it. So A plus C plus E minus B plus D plus 5 is congruent to 0 mod 11. Okay. Now, which means only possibility is that total is 29. The only possibility you can see is 20 minus 9 is equal to 11. Correct? 20 minus 9 is 11. This is the only possibility you will get, which means A plus C plus C should be 20, B plus D plus 5 should be 9. Correct? So, B plus D plus 5 equal to 20, or you can take whichever way, because A plus C plus C, if 5 is this side, you can't make A plus C plus C as 20. You check if you want. You take the maximum 7 and 8, you can't put anything else to make it 20. 20 has to be B plus D plus 5. Okay, 7, 8, 5. That is one possibility, only possibility. Okay, B and D can be any of the 7, comma 8, and ACE can be any of the 2, 3, 4, which is sum. If you sum up, you will get 9. Okay, so B and D can be arranged in 2 factorial ways. ACE can be arranged in 3 factorial ways. So total number of possibilities, total possible numbers are 3 factorial into 2 factorial, which is 12. Okay, this is a pure number theory question, and very nicely asked from the probability or combinations, okay, permutations and combinations. This is a question from ISI aptitude test, okay, Indian Statistics Institute aptitude test. One of the very good institute if you are really interested in maths. Okay, they offer B Stats and B Bachelor of Stats and Bachelor of Maths, a 3-year course in maths, actually pure maths. But after that you can do masters, and MTech also is there in that institute. It's a very premium institute of India, which has centers in several cities. You can check. Okay, next question. Out of 2n plus 1 tickets consecutively numbered, 3 are drawn at random. Find the chance that the numbers on them are in AP. Okay, in arithmetic progression. Okay, so yeah, let's see how to do this. This is just tricky but simple. Okay, number of ways to pick 3 numbers from 2n plus 1 numbers is 2n plus 1 C 3. Correct? Combinations. Okay, now we have to get the numerator. This is the denominator of the probability, right? Now you need to get the uh, numerator. Okay, among 2n plus 1 numbers, there will be n even and n plus 1 odd numbers, or n plus 1 even numbers and n odd numbers, right? It can be any of this combination possible. Okay, now if 3 numbers are in AP, if let's say ABC are in AP, then we know that 2B equal to A plus C, correct? And a 2B is always even number. Okay, so A comma C, either both can be even or both can be odd. There is no other combination possible. Okay, so A comma C should be picked up from n odd numbers or n plus 1 even numbers, or other way, n plus 1 even numbers and n odd numbers. Okay, but you cannot pick one from one even, one odd, because even plus odd is odd. 2B is even, so it's not possible. So only thing you can pick is both of them either A comma C, both of them are either even or odd. And once you pick these two, 2B is a fixed number. 2B is middle point of that, right? So there is no option for 2B. Okay, 2B has to be A plus B, A plus C by 2. Okay. So if you pick any two numbers, middle number is the third number. That's it. So B don't have any option. Okay. Now, picking any two odd or even numbers from n plus 1, even or odd numbers is n plus 1 C2. This is one option. If it is n numbers you are picking from, okay, then in picking of any two even or odd numbers from n even or odd numbers is nc2. So sum of these two is my numerator, correct? So given probability is equal to n plus 1 c2 plus nc2 divided by 2n plus 1 c3. If you simplify, you can get 3n by 4n square minus 1. This is the answer. Okay. Next. Yeah, another Indian Statistics Institute aptitude test question. If A0 equal to half and AN is defined inductively as an equal to square root of 1 plus an minus 1 divided by 2, where n is greater than or equal to 1. Show that for n greater than or equal to 0, an equal to cos xn for xn is between 0 and 90. Okay. So you are given a0 which is half, but you have to prove an is in terms of cos. How can we go? And there is a recursive equation given. Inductive doesn't same as meaning is same as recursive function. an depends on an minus 1, an minus depends on an minus 2, like that. Okay, until a0 you fix the value then. Okay, so how to do this? First we should define a0 in terms of cos. Okay, so a0 equal to half, which is nothing but cos x0. So we know that x0 is either 60, I mean 60, or it is pi by 3 in terms of radians, right? So an we can call it as cos xn, cos of xn. Okay, now you remember this equation. Now let's simplify this one. An equal to square root of 1 plus an minus 1 divided by 2. So an minus 1 is equivalent to, from this equation, cos of xn minus 1. Correct? Now we know that again I am applying same rule. 2 cos square x by 2 equal to 1 plus cos x. This is theta by 2, this is theta. Okay. So if I substitute this, an equal to 1 plus cos x. Okay, I am writing it as cos square, basically 2 cos square x by 2, right? 2 cos square xn minus 1 by 2 divided by 2. So 2 and 2 gets cancelled. We are left with cos square xn minus 1 divided by 2. Okay, which is nothing but cos xn minus 1 divided by 2. Okay, this is equal to, okay, this is equal to cos xn. Correct? Because an equal to cos xn. Okay. Now, if you see this, you can equate these angles. Xn equal to xn minus 1 by 2, or x0 equal to pi by 3. Correct? And this one, this we know the value, this already. So xn is, if I write, it starts with pi by 3, and every time I get a 2 to the power of, 1 by 2. Right? So it will become pi by 3 divided by 2 to the power of n. This is I am defining as xn. Once I know this, sorry, okay. Once I know this, at these values of xn, basically, uh, an equal to cos xn is valid. Okay. Next. Yeah, this is another Indian Statistics Institute question. S equal to theta sine pi theta by 1 plus theta, comma, 1 by theta cos pi theta divided by 1 plus theta. Okay, such that theta belongs to R and theta is greater than 0. And T is x comma y such that ordered pair, basically. Both are ordered pairs. X comma y such that, okay, x comma y belongs to R and xy equal to half. How many elements in S intersection T have? Okay, yeah, this is the interesting question. Um, Involves trigonometry and very simple set theory. Okay, so let us assume there is x comma y in that set T, okay, in S intersection T, which means it will satisfy this equation, right? Xy equal to half, correct? Xy equal to half, or these two, basically these two should be product of these should be half. So theta into theta sine pi theta by 1 plus theta into 1 by theta cos pi theta by 1 plus theta equal to half. Okay, now we know that theta and 1 by theta gets cancelled and 2 comes to the left. So 2 sine, whatever this is, you call it alpha, 2 sine alpha cos alpha equal to 1. Okay, this is nothing but 2 sine alpha cos alpha is sine 2 alpha, right? So sine 2 pi theta by 1 plus theta equal to 1. Now let's see what are the possibilities of this angle. Okay, so this is equal to pi by 2 plus, when it will be 1, when it is 90 degrees, or 2 pi plus 2 pi k plus 90 degrees, right? So this is equal to 2 pi theta by 1 plus theta is equal to pi by 2 plus 2 pi k. Okay. Now if I just simplify, I cancel pi under the both sides. I get 2 theta by 1 plus theta equal to half plus 2k. So my k is equal to theta by 1 plus theta minus 1 by 4. Okay. Now we know that for any given number, theta by 1 plus theta is always between 0 and 1. Correct? It is greater than 0 and it is less than 1. Okay. So once you know this, you apply that here, which means minus 1 by 4. Correct? This is minimum value 0. So k will be minimum value is minus 1 by 4. Maximum value of this one is 1. Okay. So it will be 3 by 4. 1 minus 1 by 4 is 3 by 4. So k is between minus 1 by 4 and 3 by 4. So only possibility for k is integer value because k is integer, right? Here 2 pi k, k is the integer. So only possibility is k equal to 0. If k is equal to 0, theta by 1 plus theta equal to 1 by 4 or theta is equal to 1 by 3. This is the only possibility where we'll get. That means there is only one element in this intersection. Okay. There is only one element in this intersection. Okay. At theta equal to 1 by 3. There is no other value. Okay. So answer is actually one element. Okay. Not theta equal to 1 by 3. Answer is one element in S intersection T. Okay. Yeah. Thank you. These are the good collection of problems for Mathematics Olympiad as well as students who are preparing for the entrance exams for engineering and other things. Okay. So keep doing maths. Till then, see you again with more videos. Thank you.